Hello students, my name is Sushant Garg and I'm back with one more question of thermodynamics which has been asked in JEE Advanced previous year paper. So this question has been asked in JEE Advanced in 2013 I think, and this question belongs to the first law of thermodynamics. In previous video we have seen the question related to JEE Advanced which has been asked in previous year related to work. Now in this video we are going to see the question of first law of thermodynamics of JEE Advanced. So this question is of match the following type, in which list 1 we have given the thermodynamic processes of 4 different systems and list 2 gives us the magnitude of possible changes in internal energy. So what we have to do, we have to calculate the internal energies of these 4 thermodynamics processes and we have to match the following with the list 2. So let us begin with the process 1, which has given as mass of water as 10 to the power minus 3 kg and it is at temperature 100 degrees Celsius. Converted, this water which is at 100 degrees Celsius is being converted into steam and at a pressure of 10 to the power 5 Pascal. The volume of the system changes. So V1 was 10 to the power minus 6 meter cube to changes 10 to the power minus 3 meter cube. Latent heat of water is given as 2250 kilojoule per kg. So we have to calculate the internal energy during this transition. So we know from the first law of thermodynamics, delta Q is equal to delta U plus work done. So delta Q must be given here is to melt the or to vaporize the water to make it a steam. So latent heat is L, suppose the mass is L, so heat given must be ml. So delta U you have to calculate and the work done will be P delta V if it is a constant pressure process. This water to steam transition is happening at a constant pressure. So M is given as 10 to the power minus 3. Latent heat is given as 2250 kilojoules, so 10 to the power 3. Delta U you have to calculate plus P delta V. Pressure is 10 to the power 5. Delta V we have to calculate 10 to the power minus 3 minus 10 to the power minus 6. 10 to the power minus 3 minus 10 to the power minus 6. So this is written like this. Now, so this 10 to the power minus 3 10 to the power 3 becomes 12250 is equal to delta U plus 10 to the power 5. When we subtract 10 to the power minus 6 from 10 to the power minus 3, we will get approximately 10 to the power minus 3 itself. Okay, so 2250 is equal to delta U plus 10 to the power 5 into 10 to the power minus 3 will get 10 to the power 2, which is 100. 2250 delta U plus 100, we get delta U as 2250 minus 100, which is approximately equal to 2050, which can be written as 2 kilojoule. So the first one matches with P itself. First one matches with P itself. Now we'll calculate the next process. We have calculated the first one. In the second we have been given 0.2 moles of rigid diatomic ideal gas. The moles is given is 0.2 and rigid diatomic ideal gas. So diatomic rigid molecule have degree of freedom 5. Degree of freedom how much? 5. So the next thing which is given here is volume V at a temperature 500 Kelvin. Volume V at a temperature 500 Kelvin. What is happening? Undergoes an isobaric expansion and the volume becomes 3V. So when the isobaric expansion happens, the volume is increased by 3 times, then the temperature will also increase by 3 times because volume is proportional to temperature in case of isobaric expansion. So temperature will become 1500 Kelvin. Now R value is given as 8 joule per mole Kelvin. Now we have to calculate the internal energy. In this case we have to write down the first law of thermodynamics mathematical equation. The delta Q is how much? Delta Q will be equal to NCP delta T because It is a constant pressure isobaric expansion. Delta U we have to calculate, or if we know, we have to calculate delta U. Now, if we know CV, we can calculate the delta U directly from NCV delta T. N is given as 0.2. CV we have to calculate from the degree of freedom. So F by 2R is the CV. So 5 by 2R we can write. So 5 by 2R, delta T is how much? 1500 minus 500. So 1000 delta T will be. So this we have to calculate. We can calculate this here. Delta U 0.2 divided by 2. 0.2 divided by 2 will give us 1 by 10 into 5 into R is 8000. So 2 8 the, sorry, 1, it will come give us 5, this 2, 4, 4000 will get, 4000 meaning 4 kilojoule. So second one will get R. Now we have to calculate the third thermodynamics process, how much internal energy it has gained or lost. The magnitude we have to calculate. So we have to move on to our third process. In third process, 1 mole of monoatomic ideal gas. 1 mole of monoatomic ideal gas whose degree of freedom must be 3, compressed adiabatically from volume 1 by 3, which is, and pressure how much? 2 kilopascal. So volume V1 is 1 by 3 and pressure P1 is this, and to volume V by 8. So this 1 by 3 by 8. So V2 will be 1 by 3 by 8. So how much? 1 by 24. P2 we don't know. We have to calculate the internal energy with this information. So for that, if we write delta Q is equal to delta U plus W, in adiabatic process this is 0. So delta U plus W gives us W is equal to, or you can write delta U is equal to minus of W. Work done in adiabatic process is P1 V1 minus P2 V2 by gamma minus 1. So in this case we know P1 V1 V2, but we do not know P2 and gamma. So firstly we calculate gamma. From degree of freedom we know the formula 1 plus 2 by F. 1 plus 2 by 3, 5 by 3 will get gamma, and from that we can calculate from the equation P1 V1 gamma equal to P2 V2 gamma. We can calculate P2. P1 value is 2, V1 value is 1 by 3, gamma. P2 value we want to calculate. V2 value is 1 by 24, gamma. Next we can arrange this in the form of in the form of P2. So what we'll get? 2 1 by 3 gamma upon 1 by 24 gamma. So this can be written as 2 24 by 3 gamma. So 24 by 3 gives us 8. Gamma value is 5 by 3. So 8 to the power 5 by 3 gives us how much? So 8 to the power 5 by 3. We take cube root of 8 first. Cube root of 8 we'll take. Then we take its power 5. 2 cube root of 8 will give us 2. Then 2 to the power 5. 2 to the power 5. 2 to the power 6. 2 to the power 6 becomes 64. So the pressure comes out to be 64 kilopascal. Now we calculate the work done. Work done is P1 V1 minus P2 V2 upon gamma minus 1. P1 is 2 kilopascal, 2 into 10 to the power 3. V1 is 1 by 3 minus P2 is 64 kilopascal, and into V2 we have to calculate. V2 we have 1 by 24. V2 we have 1 by 24. Gamma minus 1 means 5 by 3 minus 1. So we can take 10 to the power 3 as common. 2 by 3, 64 by 24. 5 by 3 minus 1 will give us 2 by 3. Now 64 by 24 32, 12, 16, 6, 8 by 3 will get, so 10 to the power 3, 2 by 3 minus 8 by 3 upon 2 by 3. So 2 by 3 minus 8 by 3 will give us 2. 2 by 3 will give us minus 2. Minus 2 by 3. So you can calculate 2 by 3 minus 8 by 3. 2 minus 8 by 3 minus 6 by 3 minus 2 we will get. This how much we will get? 10 by 3 my 2 will get cancelled. We will get 3 into 10 to the power minus 3, meaning minus 3 kilojoule work we get. We know delta U is equal to minus W, so delta U will get plus 3 kilojoule. So this is the 3 kilojoule. Are we getting any 3 kilojoule? Yes, in T. So third one is T. Now we'll calculate the fourth one. In fourth one we have given 3 moles of diatomic ideal gas. Just wait, I have to raise it. Three moles of diatomic ideal gas. 3 moles of diatomic ideal gas whose molecules can vibrate. So in vibration condition, diatomic 5 plus 2 we have to add 7 degree of freedom will get. So given how much heat given is 9 kilojoule and undergoes isobaric expansion, meaning constant pressure process is raised. So Q equal to NCP delta T we can write, and 9 kilojoule it is given, N is given as 3. Cp we can calculate from degree of freedom 1 plus F by 2 R. So Cp will get 1 plus 7 by 2 R, 9 by 2 R. Cp will get 9 by 2 R. So we can put Cp value in this 9 by 2 R Q, 9 into 10 to the power 3. 3 is the number of moles. Cp value is 9 by 2 R. We can get delta T from here. If we get delta T from here, we can get our desired answer of delta U. So 9, 3 it will become, and 3 it will become also. So 10 to the power 3 into 2 by 3 by R. We will get delta T. 3R by this will get delta T. To calculate delta U, we have NCV delta T. CV we will get F by 2 R. So 7 by 2, I think 7 by 2 R we will get. Now 7 by 2 R we will get. So 7 by 2 R when we are getting, we can write it here. 3 is the number of moles. 7 by 2 R is the CV. Delta T is 10 to the power 3 into 2 by 3 R. So 3 and 3 will get cancelled out. R and R will get cancelled out. 2 and 2 will get cancelled out. So delta U will get 7 into 10 to the power 3, which is equal to 7 kilojoule. So this answer we will get fourth ka Q, 7 kilojoule. Fourth ka Q. So C option is correct. I hope you enjoyed the video. This is very informative related to the question of which has been asked in JEE Advanced. You can get an idea how question has been asked in the form of match the following. And this question belongs to first law of thermodynamics. And just wait for the next video. We'll upload more questions of thermodynamics related to JEE Advanced in the next video. I hope you enjoyed the video. If you have any queries, any doubts, please comment. I will answer it as soon as possible. Okay, that's it from this video. Bye.